I'm going to tell you about the strangest thing I've ever discovered, and I discovered a lot of strange things, but this one surpasses them all. Because this discovery says that order and chaos, these two forces that seem opposite, that seem like enemies, that seem to inhabit different sides of the universe, are in fact the same thing, governed by the same rule, measured by the same equation, united by a single idea. And this idea has a name. Entropy. I know what you're thinking. Entropy is disorder. It's what your physics teacher taught you. High entropy means chaos. Low entropy means order. Entropy always increases. The universe is inevitably heading towards maximum disorder. Everything falls apart. Everything mixes. Everything degrades. This is the classic view. And it's not wrong. But it is terribly incomplete, because when I took the same word, entropy, and put it into information theory, something unexpected happened. Entropy is no longer just about disorder. It became about information, about surprise, about the amount of uncertainty in a message, and suddenly the same equation that described chaos also described order. The same formula that measured the disorder of a gas also measured the informational content of a message. Two worlds that seemed completely separate, thermodynamics and communication, turned out to be mirrors of each other. Let me explain how I got here. In the 1940s, I was trying to solve a practical problem at Bell Laboratories. How to measure information. It seems simple, but no one knew how to do it. People used the word information all the time, but no one had a precise definition. No one could say, this message contains exactly X units of information. There was no unity. There was no scale. There was no formula. It was like talking about temperature before the thermometer was invented. Everyone felt it, but no one measured it. I needed a measure. And to find it, I asked a question that seems simple but is profound. What makes a message informative? What makes a message carry more or less information? If I tell you that the sun will rise tomorrow, is that information? Technically, yes. But it's so predictable, so obvious, so certain, that in practice it doesn't tell you anything you didn't already know. It carries almost zero information. Now, if I tell you that a meteorite is going to hit Earth tomorrow, that carries enormous information, because it's unexpected, surprising, unlikely. Do you notice the pattern? Information is linked to surprise. To the unexpected, unlikely. The more surprising a message, the more information it carries. The more predictable, the less information. And if it is completely certain, completely predictable, without any margin of doubt, the information is zero. Because there are no surprises. There is nothing new. There is nothing you didn't know before. I formalize this intuition into an equation that calculates, with mathematical precision, the amount of information produced by a source. And when I wrote this equation on paper, I looked at it and felt goosebumps, because I had seen that equation before, not in communication theory. In thermodynamics, it was Boltzmann's formula for entropy. The same structure, the same way, same math. The sum over all possible states of the product of the probability and the logarithm of the probability with a negative sign in front. Identical, not similar. Not analogous, identical. This disturbed me. And it fascinated me at the same time. Because Boltzmann entropy measures something completely different, measures the disorder of a physical system. How many different microscopic arrangements are compatible with the observed macroscopic state? A gas in a box has high entropy because the molecules can be arranged in trillions of different ways, and the gas still looks the same on the outside. You look at the box and see a uniform gas. But inside, molecules can be in any position, with any speed, in any direction. The number of possible arrangements is astronomical, and entropy measures this quantity. A perfect crystal, on the other hand, has low entropy because the molecules are trapped in fixed positions, arranged in a regular grid. Few possible configurations, little freedom, little surprise if you could peek at the microscopic arrangement. Boltzmann entropy is about possibilities, about the number of ways things can be without appearing different on the outside. And my entropy, it was also about possibilities, about the number of different messages that a source can produce, about the uncertainty of the receiver before receiving the message, about how many surprises are possible. The same underlying logic, same math, the same equation. Two apparently unrelated phenomena, molecular disorder and communicational uncertainty, described by the same formula. I talked to John von Neumann about this. He was one of the few who understood thermodynamics so much that huge communication theory in enough depth to appreciate the connection. And he said to me, half seriously, half jokingly, call it entropy. Nobody really knows what entropy means, so in any debate you're going to have the upper hand. The joke is good, but the truth behind it is profound. Because the reason no one really knows what entropy means is that entropy is one of those ideas that transcends the field in which it was born. It is too big for a single discipline, too big for a single interpretation. In thermodynamics, entropy is disorder. In information theory, entropy is uncertainty. In statistical mechanics, entropy is the logarithm of the number of microstates. In communication, entropy is the minimum bitrate required to encode a source. 4 different settings, 4 different contexts, the same equation, and the question that obsessed me for years was, is this a coincidence? Or are these 4 things, on some deep level, the same thing? The answer, as I have come to understand over time, is that they are the same thing. And this answer is not just my intuition. Decades later, physicist Rolf Landauer proved something extraordinary. He showed that erasing a bit of information, a single bit, requires a minimal amount of energy. This energy is directly proportional to the temperature of the system and the logarithm of 2. It's a tiny amount, but it's real, it's measurable, and it is fundamentally thermodynamic. This means that the information is not abstract, it's not purely mathematics. She has one foot in the physical world. Deleting information generates heat. Processing information consumes energy. Information entropy and thermodynamic entropy are not just mathematically identical, they are physically connected. They are the same thing seen from different angles. And this is the discovery that unites order and chaos under the same rule. Because what entropy really measures, in all these contexts, is the same thing, the degree of freedom of a system. How many possibilities are open? How many paths the system can follow? How many configurations are compatible with what we know? A disordered gas has many possible configurations. High entropy, lots of freedom. An ordered crystal has few possible configurations. Low entropy, little freedom. An unpredictable message has many possibilities for the next symbol. High entropy, lots of information. A predictable message has few possibilities. Low entropy, little information. In both cases, entropy measures the same thing, the size of the space of possibilities, the width of the horizon of uncertainty, the amount of potential surprise. And here is where the union of order and chaos becomes truly fascinating. Because in the classical view, order and chaos are opposites. Order is good, chaos is bad. Order is organization, chaos is destruction. But through the lens of entropy, the relationship is much more subtle. Chaos is not the enemy of order. Chaos is the raw material of information. Without chaos, without uncertainty, without surprise, there is no information. A perfectly ordered universe, where everything is predictable, where nothing surprises, is a universe without information. No communication, no news. Without life, probably, since life depends on variation, mutation, chance. Think about it. If the result of every coin you flipped was always heads, there would be no information on the toss. If every message you received was exactly what you expected, there would be no real communication. If every genetic mutation were eliminated, there would be no evolution. Chaos, randomness, unpredictability are what generate information. It's what makes communication possible. It's what allows new things to happen. But on the other hand, total chaos also destroys. A completely random message, without any structure, without any pattern, is pure noise. It carries maximum entropy per symbol, but communicates nothing that a human could use. It's like a radio tuned between stations. Maximum chaos, maximum entropy, zero useful meaning. Real communication, useful information, lives in the middle. Between total order and total chaos, between absolute predictability and absolute randomness, human language is a perfect example of this. She is not completely predictable. If it were, it wouldn't carry information. Each conversation would be identical. Every book would say the same thing. Each message would be redundant, but it's not completely random either. If it were, it would be incomprehensible. It would be noise. It would be like trying to read a page of random letters. No meaning, no default, no communication. Language lives at the exact point between the two. It has grammar rules that create structure. It has vocabulary that limits possibilities. There is context that makes some words more likely than others. But within these restrictions, there is freedom. There is space to say new things, to surprise, to create, to inform. When someone says something you didn't expect, within a structure you recognize, this is communication. This is information. And the value of this information comes precisely from the tension between what was predictable and what was surprising. If I tell you the sky is blue, the structure is perfect, but the surprise is zero. If I tell you XKQBRMPLF, the surprise is maximum, but the structure is zero. Neither communicates effectively. Real communication lives in the middle. And entropy measures exactly that. Not how much chaos there is, not how much order there is, but the balance between the two. The amount of information that emerges from the tension between structure and surprise. Between what you expect and what actually happens, entropy is the measure of this tension. And that's why it unifies order and chaos, because he's not on either side. It's in the middle, at the point where the two meet, at the point where the structure creates space for surprise, and the surprise takes on meaning because of the structure. This has implications that go far beyond communication. In biology, life is exactly this balanced. An organism is highly ordered. It has structure, organization, standards, but this order is not static. Within it, there is variation, mutation, genetic recombination, small doses of chaos that allow adaptation, evolution, survival. An organism without any variation, without any chaos, is perfectly adapted to the current environment, but is incapable of adapting to changes. It is doomed to extinction when the environment changes. And the environment always changes. Life needs order to function and chaos to evolve. It needs both. And entropy measures the dance between the two. In the brain, the same principle operates. Neurons do not fire in a perfectly ordered or perfectly random way. There are patterns, rhythms, synchronizations, but within these patterns, there is variability, fluctuations, apparently random shots that in fact allow flexibility, creativity, adaptation. Neuroscientists have discovered that brains that operate near a tipping point, on the border between order and chaos, are the most efficient at processing information. Not too orderly, not too chaotic. At the optimum point. At the point where entropy is maximum given the constraints of the system. The healthy brain is a system that has navigated the balance between order and chaos. And that balance is, again, entropy. In thermodynamics, the second law says that the entropy of an isolated system always increases. This is often interpreted as the universe is heading towards chaos. And in a sense, it's true. Hot coffee cools down. The ice melts. Buildings collapse. Mountains erode. Everything tends towards uniformity, mixture, non-differentiation. But when I look at this law through the lens of information theory, it says something different. He says that uncertainty always grows, that the space of possibilities always expands, that the amount of information needed to describe the microscopic state of the system always increases. It's not just destruction, it's expansion. The universe is not simply falling apart. It is becoming more complex, richer in possibilities, harder to predict, and that is, in a way, more interesting. A zero-entropy universe would be a dead universe. No movement, no change, no surprise, lifeless, no information. Increasing entropy is not the death of the universe. It is the condition for interesting things to happen. It's what allows stars to burn. May planets form. May life emerge. That molecules combine in unexpected ways. That mutations generate new organisms. Let brains think new thoughts. Each of these processes increases the entropy of the universe, and each of them creates something new. Entropy is the price of novelty, the cost of cosmic creativity. When I put all this together, when I saw that the same equation described the disorder of a gas, the uncertainty of a message, the freedom of a system, the capacity to innovate of an organism, the creativity of a brain, I understood that I had stumbled upon something much greater than the theory of communication. He had stumbled upon a universal principle, a principle that connects physics with biology, engineering with neuroscience, thermodynamics with linguistics, and that principle is entropy. Not entropy as disorder, not entropy as chaos, but entropy as a measure of possibilities, as a quantification of the space between what we know and what we don't know, between what is right and what is surprising, between structure and freedom. This is the real entropy, complete entropy, the entropy that unifies, and the rule that unites order and chaos is surprisingly simple. The entropy of a system depends only on the probability distribution of its states. If all states are equally likely, entropy is maximum. Total chaos, total uncertainty. If only one state is possible, the entropy is zero. Total order, total certainty. And between these two extremes, there is an infinite spectrum of combinations, of balances, of mixtures of order and chaos. And each point on this spectrum has a precise value of entropy, a number, calculable, objective, universal. This means you can compare things that seem incomparable. You can compare the disorder of a gas with the uncertainty of a language. You can compare the complexity of a genome with the compressibility of a digital file. You can compare the noise of a communication channel with the temperature of a thermodynamic system. Because everyone is measured by the same ruler. They all obey the same equation. They are all manifestations of the same principle. And there is a practical consequence of this that is extraordinary. In engineering, knowing the entropy of a source of information tells you exactly how far you can compress the data without losing anything. In thermodynamics, knowing the entropy of a system tells you exactly how much useful energy can be extracted from it. In biology, knowing the entropy of a genetic system tells you how much diversity it can maintain. In each case, entropy defines a limit, a roof, a border between the possible and the impossible. And this border is the same in all fields, not similar. The same, because the math is the same. This is what I call unification. When an idea born in one field proves to be valid in all fields, when an equation discovered to solve a problem solves all problems of the same type, when the same rule governs the gas, the message, the gene, the neuron, and the black hole, few ideas in the history of science have reached this level of universality. Newton's gravitation is one. Darwin's evolution by natural selection is another. Einstein's relativity is another. And I believe, with the conviction of someone who has seen mathematics work in domain after domain, that entropy is in that group, not as a poetic analogy, like a mathematical fact. Some people are bothered by this. They are uncomfortable with the idea that order and chaos are governed by the same rule, because they like to think they are irreconcilable opposites, that the universe is a struggle between the order that builds and the chaos that destroys. And on a certain narrative level, this vision is satisfying. It gives reality a plot, heroes and villains, creation and destruction. But mathematics doesn't care about narratives. Mathematics describes what it is. And what it is, when you look closely, is that order and chaos are not opposites. They are ends of the same spectrum, measured by the same magnitude, governed by the same equation. And most of the interesting things in the universe, life, communication, creativity, devolution, intelligence, all happen in the middle of this spectrum, at the point where there is enough order for there to be structure and enough chaos for there to be novelty. At the point where entropy is neither maximum nor minimum, at the point where the tension between the two is most productive. The universe is not a battle between order and chaos. It's a dance that never stops, that never repeats itself, that with each step creates something that didn't exist before. And entropy is the music that dictates the rhythm, the same music for the gas that expands, for the message that travels, for the gene that mutates, for the brain that thinks. When you send a message and it reaches the other side, order and chaos work together. The error-correcting code order protected the message. The chaos of noise tried to corrupt her. And entropy set the limit to how much could be protected and how much would inevitably be lost. When your body copies DNA and produces a new cell, order and chaos work together. The order of the replication mechanism faithfully copies. The chaos of molecular fluctuations introduces variations. And entropy defines the balance between fidelity and innovation that allows life to continue evolving. Everything that exists, everything that works, everything that lives, operates in this balance. And the discovery I made, the discovery that united order and chaos under the same rule, is simply that this balance can be measured. It can be calculated. It can be optimized. With a single equation. With a single concept. With a single word. Entropy. Chaos has order. And the first found the ruler that measures both.